name is Wes Caldwell. I'm an architect at ISS, and I'm going to talk about delivering on the promise of big data at the tactical edge. And so there's probably a lot of you who are wondering, what's the tactical edge? And I'll get into that. ISS, I work for ISS Incorporated, and we do a lot of DoD and government business. And so tactical edge is sort of a term that's used in that domain. So just high-level agenda, talk about ISS real quick, start discussing the intelligence information enterprise, which is the massive amount of data that we're bringing in on government networks. Some of the challenges in tactical environments and how you deal with big data, how we're managing that type of data. The need, what do analysts really need from big data? That's really the crux of the matter. The tools that we're using to apply towards these big data problems, data analysis, analytics. The spectrum of analytics that we're using at ISS for our customer base. And then I'll go through some use cases, some examples of applied analytics, and I'll get into details on those when we get there. So, who are we? Who is ISS? We're a software company based out of Colorado, and we do a lot of business with the government and federal markets. We obviously we're a recognized leader in the DoD, and we have a large customer base of tens of thousands of users across a large amount of products. We've been in business for about 15 years, and just to segue into, here's some of the programs. We have sort of a large spectrum of operations encompassing all the major Air Force, Army, Navy, Marines, as well as federal agencies. So this is just an example. I'm not going to walk through every product that we have, but a particular interest is down at the bottom here. We have what I call our tactical programs. And these are actual programs that we have over 100 ISS employees in Afghanistan today supporting operations of military operations in Afghanistan. So I'm going to talk really about, that's when I say tactical edge, I mean the networks and the people that are forward deployed supporting all of our customers. So that's really what tactical edge means. So I want to focus mainly on this area here. So what is the intelligence information enterprise? It is definitely a big data environment. It is a lot of data coming in a lot of different ways. In military intelligence and analysis, there's hundreds of data sources that we're trying to bring in and synthesize into knowledge, information knowledge. There's media, tons, hundreds of thousands of documents, images, various media formats that are coming in, Word documents, PowerPoints, PDFs, et cetera, et cetera. There's human intelligence, and that is human interactions. That's personal interactions. Those are people on the ground interacting with other people and writing reports and submitting those into this enterprise. And those are particular criticality because it has a lot of the personal type interactions that only you can get from a human-to-human exchange, rather than something like a sensor, an imagery, a radar, etc. So geospatial intelligence, very important. Obviously putting things on a map, putting things in time and space. A lot of geospatial intelligence collection obviously happening all around the world, especially in Afghanistan. Open source intelligence, another critical element to this information enterprise, and a lot of it. Those are, examples are news feeds, in that case the BBC News there. Blogs, RSS feeds, all the types of things that you can generally just cull off the internet, feed into this enterprise. Imagery and video, Predator video, thousands and thousands of hours of video that's recorded over many, many years, all brought into this information enterprise. And obviously many, many more, too numerous to name, but basically trying to paint the picture here that we've got a ton of information coming in, and you have analysts that are trying to look at all this information and make sense of it, and trying to understand how to extract information and knowledge from this massive enterprise. And each one of these data sources, if you will, collectively, well, each one doesn't necessarily represent big data, but collectively, you add all these up, and now you have hundreds of millions of records coming into your environment, and you're trying to process that information. So what are some of the challenges in tactical environments? And again, when I talk about tactical edge, I talk about these remote sites where we have analysts on really spotty comm channels. And so some of the challenges are, I mean, literally you have a spider web of data sources that collectively hold hundreds of millions of data elements, and they're geographically distributed around the country or wherever your area of responsibility is. But it's a challenge because the geographically dispersed nature of the data sources and the communication channels between those elements, it's very hard to move data around. It's very hard to access data. And a majority of the data is unstructured. So obviously in the ever-evolving world, the world we live in, obviously unstructured data is becoming 95% of the information that we're trying to exploit and analyze. So majority of that data is unstructured or semi-structured, which makes human analysis more challenging, obviously. An analyst needs to look at 100,000 documents and try to understand what he's trying, what we're trying to get out of those documents. It takes a lot of time and a lot of effort, and obviously very challenging when the document's unstructured and not relational in nature. So, and then you have the challenge of multiple networks. There's various segmented, classified networks that only allow certain access to these information. So it's very hard to kind of holistically bring that data together and get a clear picture of all your data because it's spread across multiple segmented networks. So another challenge. And system and data interoperability. Obviously, in military operations, you have hundreds of systems, and they all are trying to interoperate or exchange data in various formats. And there are various DoD data exchange format standards, but the adoption of these systems and how they come online and how they interchange is very challenging because they're on different time schedules, different releases, and it's very challenging for the systems to interoperate with each other. So these are all just basic challenges of operating in a tactical environment. And obviously the last one, the communication lines are very high latency, low bandwidth. So it really provides a challenge for a big data environment. How do you bring this data in? How do you manage the data that you're trying to analyze? So basically, this is how our analysts feel. A lot of our customers, they have this massive haystack of information, and they're trying to whittle that down and try to understand and discern what they need to get from that information. They're not trying to find the needle per se. They're just trying to whittle it down so they can manage it and deal with it in a more cohesive way. So what do we do with all this data? That's the real question. So what are our analysts looking for? Well, again, our experience with our customers is obviously they're looking to extract knowledge from this massive heterogeneous set of data, providing actionable intelligence. So what does that mean? That means whittling down that haystack and finding the information they need to make a decision to say, okay, I have the information, I have my evidence, and now I need to make a decision to move forward and do something about this. And obviously search and discovery are key. They're critical elements to the ability to whittle down the haystack. They enable the analyst to do searches and queries against a large corpus of information and kind of, cull that down to just the essential pieces that they need. Then they can move forward and actually do analytics on that information. So it's really critical that, especially in a tactical environment, that we provide the tools that allow them to do this. And Solr and LucidWorks Enterprise are key to our architecture and how we're providing these capabilities to our customers. So it essentially allows them to do geospatial, temporal constraints, queries to cull that information down, find the critical information. Then we talk about putting that through the analytic pipelines, entity extraction engines, text analytics, the various analytics that we need to apply. But we don't necessarily apply those analytics at the holistic billion record level. We apply those analytics at the 100,000 record level. So you allow them to kind of discover information, bring that information into what we call the sandbox, the analyst sandbox, and we allow them to then apply analytics to that information, which allows them to target a particular problem domain or question they want to ask their information. So it's very critical. And again, in these tactical environments, they don't have access to the billion records of information. They're trying to filter that down into a manageable set of information. And obviously, analytics are very specific to a problem domain. So you're going to ask questions of your data if you're doing counterterrorism or counter-narcotics or financial analytics. So you're going to ask it different questions. So your analytics are really targeted at that particular problem domain. So we provide, ISS, we have a technology suite that we provide our customers, and it's evolved over time. Again, we've been in business for 15 years now, and we provide a suite of analytical tools that allow the type of information to be exploited, queried, segmented, displayed, visualized, analyzed. So it's a suite of tools, web-based, thick client-based, services-based, service-oriented architecture. But it's a set of tools that they're allowed to sort of exploit the information. And again, it's after that information's sort of been culled down. So just some examples of some of the tools that we provide. Search and discovery, as I said, is key to our ability to allow the analyst to get to the information they need. So we've got, obviously, a query mechanism, if you will, that aggregates structured and unstructured and links and relationships and associations. It allows you to query that information and bring all that information back into your quote-unquote sandbox where you can do analysis. We obviously have integrated search. That's critical, as I've said. We've integrated some natural language processing capability through GATE that allows you to do more human-readable questions for your data. So you could say, show me all events that happened within the last 24 hours. And that would be turned into a set of structured queries and unstructured queries into Solr that allow you to pull that information back. But the analyst barrier of entry is much lower when you're talking natural language. So that helps our analysts really kind of ask human-readable questions. So that's some of the capabilities. Some other stuff, we have a visualization architecture on top of the query and data access layer, obviously, that allows you to represent data geospatially in the maps displays. We have data density plots. That's the lower one there. Obviously, tables and timelines. Link analysis is real critical, obviously, because you're trying to identify relationships between entities. And you can start with simple, just this is related to this, or you can have analytics that run that actually bring up more richer derived relationships, if you will. And obviously, we have a set of statistical analysis tools, grids and graphs and charts that allow you to visualize data in more of a statistical display format. But again, all built on top of the search and discovery core that includes Solr and LucidWorks Enterprise. So, excuse me. So, evolution to big data. So obviously, as any company or any solutions provider that's been around for a while and has provided solutions to their customers over the years, we started out in the late 90s with simple desktop clients tied into relational databases. The intelligence information enterprise that for our customer base was largely relational. A lot of relational databases, just trying to aggregate all those relational databases. And as you get into the 2000s, we've started building web-based UIs into that same architecture. Then when we started getting into the late 2010, 2011, 2012, obviously the nature of the data started changing. The majority of the data was unstructured. We had to integrate free text search engines. Solr and LucidWorks Enterprise was what we chose. Obviously, to allow us to provide a unified index into that structured and unstructured world so we could search across large amounts of data. So the scalability became an issue with just the traditional relational databases. So now we were tying in unstructured text indexes. Obviously, and then moving forward, supporting big data, cloud-based data stores, NoSQL variants, HBase, Mongo, Accumulo, these large, obviously scalable NoSQL variants. And now we're kind of in this mode where, obviously 80% of the data we're pulling in is unstructured, so we're into this polyglot persistence model where we've got a lot of data coming in, but we need to represent and store that data in various ways, various perspectives as we call it. And that data lets us ask, the data perspectives are optimized for the questions we're asking our data. So for example, we'll put it into Solr LucidWorks, or we'll put it into AllegroGraph or Neo4j, a graph database. So we're asking for relationships between our entities. RDF triple stores with the graph databases. Content repositories, JCR, Apache Jackrabbit, we use that quite a bit to store content. Obviously, we still tie into the traditional RDBMS as well. So we kind of try to bring that all together into what we call this polyglot persistent model, which allows us to sort of aggregate all that data, be able to scale out, and be able to query that data, bring that in for the analyst. So the nature of the business of how we've evolved into this is starting out, it's starting to now become this big data problem. We're trying to manage all the data coming in. But the goal has always been that we have a unified data access architecture that allows our analysts to get to the information they need quickly, efficiently, and to get to the meat of what they're trying to do. So that's really the evolution. It really just moves in that direction as the nature of the data has changed and how we want to access the data has changed. So if we look at this is a representation of the spectrum of analytics that we've worked on with a variety of our customers. And if you take it as it's an onion and there's a core to this onion, or a donut, if you will, the core element of the analytics that we enable for our customer is search and data management. So search and the ability to manage large amounts of data is key to enabling those analytics that wrapper that. So you start at that core and you start moving out. Well, we have 5 major categories that we're dealing with right now in the DoD: text analytics, trend analysis, geospatial analysis, activity-based intelligence, and social network analytics. So each one of those has unique capabilities that our customers want and are striving for. Obviously, in the text analytics, this is a pretty familiar realm for most people in big data. You have entity extraction, concept extraction, clustering of data. In trend analysis, this is really it's statistical analysis. You're looking for trends in your data based on historical evidence and trying to predict future events, essentially. Geospatial analysis, obviously, you have data density, spatial density. I'll go into route analysis, exactly what we've done there. And activity-based intelligence is correlating events to each other. Complex alerting, complex event processing engines, Bayesian reasoners, things like that. Social network analysis, obviously, the complex interrelationships between social networks. These could be gangs in LA. It could be drug cartels in Mexico. It could be terrorist networks around the world. It's whatever you're trying to represent a relationship set across a large amount of data. So there's proximity, there's clustering, there's pathing, there's degrees of separation, etc. So we kind of characterize kind of our customer problem domain space in this sort of wheel fashion. And obviously the outer rim is really your user experience. You're building tools that you apply on top of these analytics, and that's really the key piece as well, is that you have to deliver this in a way that people can use, that people can actually interact with, and they can understand, and they feel like they have control. You can't provide an analytic to an analyst and tell them, well, just trust it. Just trust it. This is exactly, this is coming up with the right answer. They always ask the question, well, how did you get to this point? How did I get from point A to point B? How did you infer this relationship between this entity? So, the UX around it is key, and we've put a lot of effort into making that usable. So I'll go into a few use cases here of how we apply analytics, again, across our customer base. This one is I'll call it low-tech analytics because it's not really big data, but it's called route analysis. And this is, if you're familiar with this shot, this is Baghdad. This is in Iraq. So this is an old snapshot from Iraq. But basically what this is, it's a basic statistic analysis capability, geospatial analysis and statistics. So our U.S. forces in operations and military operations, they will get in Humvees and they'll drive from point A to point B. And along the way, they might collect information. They might just be moving materials or whatever they need to do to go from 2 points. So what this is they draw the route that they want to go. So they just draw it on the map and say, I'm going to go from point A to point B. And what happens is it actually enables search and query, again, using Solr and LucidWorks and relational data stores as well, to kind of show, in this case, all of the IED incidences that have occurred along that route historically. And so, okay, that's great. So you have a map display with IED attacks in red, IED explosions in yellow there. So it's showing you kind of a historical perspective. But then you add in some of the statistical analysis displays, and it kind of shows you trends in your data, that particular parts of times of the day, particular days of the week. So if somebody's planning on driving this route, and they notice that at a particular time in the red there in the grid, that there seems to be a high propensity for attacks in that area at that time, they will choose not to drive that route at that particular time of day. So it's really basic statistics against a historical set of data that has made a significant impact to safety of our troops. So pretty low tech as far as big data is concerned, but very significantly impactful in how that's been applied. So moving on, social network analysis. So we do a lot of analysis of complex relationships between entities. Those entities could be anything. Obviously, the point of SNA is to exploit links and relationships between nodes and entities. So you're trying to understand how things are related and where the critical nodes in your networks are. This could be IP addresses. This could be servers. This could be people. This could be entities. It could be whatever you want it to be. But you're trying to identify really the critical nodes that influence the rest of the network. So you have obviously analytics that are running that do proximity and degrees of separation and critical nodes, outliers, all these types of things. So that's just an example over here of, I think this is against some open source news data, actually, with particular cartels in Mexico, I think is what that is. But basically, it's just an example of, finding the closest route point between two entities and then doing some of the SNA analytics against that to provide some kind of visualization that the analyst can make a decision or discern some information from. So obviously, Solr, in this case, provides quick access to the information, but really how we derive and store and persist these types of graphs is in a specialized data store in a graph database like Neo4j, Allegra Graph, these RDF graph data stores. That allows us to quickly query, efficiently query essentially and render that information as you continue to drill down into your network. So that's social network analysis. Another example of an analytic that we have is correlation and fusion. And essentially what that is we have a variety of data sources and data links coming into various systems that we maintain. And you're trying to correlate, you have multiple sensors and data sources that are picking up the same thing. So we'll take a commercial aviation example, for example. So you have a plane flying into Logan Airport or flying out of Logan Airport. And there's multiple sensors picking up that plane. There could be somebody on the ground at the runway just blogging that, hey, I just saw a plane took off, and the tail number is 1234. Then you have a radar that picks up that plane as well, and it has a track that is saying, okay, there's a plane flying. And you have all this information feeding into a system, and you're trying to correlate the fact that the blog and the radar signal and various other sources that are coming in are the same entity. So you want to kind of fuse that data into the same track, if you will. So, I mean, it's a simple example, but essentially we're doing a lot of this with some of our customers. And of course, you know, we're pumping that data into the Hadoop ecosystem, into HDFS, into HBase, and using MapReduce to sort of do that deconfliction. So we're using algorithms to kind of compare, like, you know, in time and space, trying to figure out exactly where these entities are similar, and we try to fuse that information together. So obviously this is, you know, it allows you to have situational awareness, allows you not to have your map cluttered with 1,000 different objects that are the same. And so you're doing sort of that fusion. A lot of times the analyst has to go in there, and we call it gray matter fusion. They come in and actually will fuse that data themselves and take two tracks and say this is the same thing. And obviously the importance of this is that if you have different sensors picking up the same information, you get a richer set of representation for that entity if you can kind of pull those two together. So one sensor could have a better way to record speed, if you will, of the aircraft. Another could record better what type of aircraft it is. And if you fuse that data together, now you have a more complete picture of what you're trying to track or what you're looking at. So much, you can enhance and enrich your data in that way. So obviously text analytics, this is a pretty traditional analytic that everybody's probably familiar with. But we're doing a lot of this obviously with our customers as well. And it's all about combining the structured and unstructured data into something like LucidWorks Enterprise or Solr, and allowing the analyst to relate entities between each other, do entity extraction. We use GATE quite a bit to do entity extraction and natural language processing, as I mentioned before. Initially, we kind of started with a thick client implementation using some algorithms from Stanford Research to do clustering, classification, and NLP. And then now we're kind of migrating that into the enterprise, and it's being put into a service layer, a middleware essentially, that's allowing us to scale better, pipe more information through, do a lot more on the analytics side. Here's an example of, we talked about natural language processing before, but this is an example of how in one of our applications, we actually run a sort of a map natural language query which maps to an actual category, if you will, a query category, which then drives these displays to be displayed. This is an example of sort of a human-readable query format where you could say, you know, show me all the IED routes that happened along MSR Patriot, which is just a route, mean supply route in MSR, in the last 30 days within 500 meters. So then that turns into, obviously, a set of queries into Solr and into relational databases to plot the track, show the results, you know, do all the various display types. So it's sort of an aggregated query based on a human-readable natural language query constraint. So anyway, I mean, this was some examples of analytics. That's really, that's the end of my presentation. I know I cut it a little short here. But any questions?
Clustering and classification, you said that's all proprietary code. Are you using any tools?
No, we were using the Stanford, the SRI libraries out of Stanford Research. Yeah, originally we had it running in a thick client, in a Java application. And we were kind of moving that capability to the enterprise middleware. So it allows us to scale. It's the same libraries, but it's just moving it to a more scalable solution so we can now pump more information through. Originally it was, we would bring all the information into the thick client and then allow us to do clustering based on a selective set. And now we're kind of sort of putting that into the enterprise to allow us to do more clustering at a higher level, higher scale. So same libraries, but just different application. Any other questions? Yeah. No, it's n degrees of separation. That's what I meant. Yeah. Not where people are standing. Yeah. Any other questions? Oh, yes. So,
what do you, in your simple analytics, your route analysis, what were you doing? What were you using for geospatial analytics on that?
well, that was, really the constraint on that was geospatial queries to relational databases at that point. And we're doing a lot of, it depends on the database, obviously. The system we have is called WebTAS. It allows you to tie into any relational data store to store that information. If that database supports geospatial constraints like Oracle Spatial or SQL Server Spatial, then we can leverage the database technology to kind of do those geospatial boundaries or polygon queries. If not, we have to post-process that, and it slows it down a little bit. So say it's, if it's Postgres but not PostGIS, for example, then we would pull that information in and post-process that into a geospatial library. So we typically leverage where we can the relational store to maximize, and if we can't, for example, Solr, simple polygons. We can't do corridors or, we can do bounding box. So we'd have to do a minimal bounding box, minimal bounding rectangle, and then to post-process that if we need to do a route, for example. Thank you very much.